Welcome to a tutorial about using the online calculators and calculating data on the IOL Master 500. And the reason we do this is because the 500 doesn't use any of our more modern formulas. So we have to, in order to get the best results for our patients based on this biometry, which I think is very concordant with the IOL Master 700, is to plug the data into the Barrett II calculator or the Barrett Toric Calculator, and see what lens powers we get from that. So let's go ahead and try a few of these. I'm going to actually do about 12 patients here. I think it'll give us a lot of variety. So we'll start with entering data. So doctor name, we can just do mine, patient name, and ID. Of course, you'll plug these in well. I just, for the sake of HIPAA, I'm not gonna expose any patient's data here. The lens we're gonna use is the all the Johnson & Johnson lenses will have the same A constant. Let's see. And you know what? We'll just write the A constant here. It's 119.3. And of course, the lens I'm using here is the Odyssey. And just a few notes on that. Odyssey is any Johnson & Johnson lens. Odyssey, iHands, the two that I use, are going to be 119.3. If we're going to use the Alcon Panoptix, Panoptix Pro, that's going to be 119.1. 119.1 is also for the LAL or the LAL plus. So really you're dealing with just two numbers here. If we're doing any Johnson & Johnson lenses, it's the 0.3. If we're doing anything else, basically with me, it's the 0.1. So of course, most of these we're going to be doing the Odyssey at 0.3. And I like to think, Odyssey trifocal 0.3, and the LAL monofocal, 0.1. Nice way to remember. Okay, so back to doing this. We have to do one eye at a time on this one. Some of the European calculators you can do both eyes, but I really think the Barrett calculators are it's what I'm used to, and I think it's a very fine calculator. So we're gonna use Barrett here. So flat K, you can see is always K1 here, 40.18. So type that in. Tab over down to flat axis, so you can see the axis here at 3, and 41.11 is K2, which is the steep axis, and then 93. So of course these are going to be always 90 degrees apart. Axial length, AL, 23.93, and optical ACD, you can see ACD here, 2.92. And target refraction, always 0 for our multifocals. You probably don't want to change this for, even if I would just keep it at 0 for everything. SIA, I keep it at 0, even though I am inducing SIA, but I don't want the printout to take that into account. And incision location, I again, don't want it to take that into account. So lens thickness, let's see, I don't think the IOL Master 500 gives a lens thickness, but let's just double check. No. So for lens thickness, let's just plug in 4.5. I don't know of any there's a gap here. It just means I don't think Barrett actually uses these numbers. I think this is more when you look back on it for reference. That's the only available data you have, and you were curious what the lens thickness was on the biometry. You just have that as reference, but didn't think Barrett would use that as a part of the calculation. White to white is here, 12.1. So now we're complete here, and let's just double check. We have to click and designate the eye. So this is the right eye, OD. And let's see. Well, we're not going to choose any of that other than just to designate OD. You can see when you push that, it says right eye and puts the nose over here. So now we click calculate like that, and then we go to, yeah, so you got to give it a good 5 seconds. On my computer, about 5 seconds, but once it's done calculating, it spits out these lines, where you designate an incision, flat axis, steep axis there, and then that's your raw data. Then you scroll over to Toric IOL, and you can see this is the result. So what we'll do is, at this point, you'll double check against your chart all these numbers. So flat K40, 0.18, steep K41.11, yep, checked. A constant, yep, we're going to use the trifocal Odyssey, and axial length 23.93, 23.93. Okay, so now what we're looking at here is, first we're going to pick a lens power. And so it's saying here that when the power is 23.5, the spherical equivalent is basically what the, if everything goes perfectly and, healing's as predicted, the patient will have a minus 0.13 refractive outcome. Remember, these lenses come at half diopter power, so you can see they jump quite a lot. About 0.4 here and then 0.4 here. So this is the closest to 0, and of course it's highlighting in blue to make it much easier for us to select. So that's the one you want to go for first minus. First minus means this is the first plus and this is the first minus. Odyssey, always the first minus. So that's the lens we want, 23.5 Odyssey. Then you scroll over down here and it tells you what power of toric or astigmatism correction we should use. Well, of course, in America we don't have T2. T2 means 1 diopter of cylindrical power on the lens. And you can see if we were in Europe and we used T2, we'd get a pretty good result, 0.3 diopters of astigmatism. If we use the T3, which is the first available toric in America, we'd flip the axis and end up with like 0.7. We don't want to do that. So for this case, we want to go with non-toric. So basically just the non-toric 23.5. So that's how you read this chart. What you'll do next is you'll push this and it'll spit this out. And you definitely want to load this in there. This is a legal document for doing surgery. Load this, please load this into Nextech or whatever the chart we're using. So go ahead and save that, and save that. Now we go on to the next eye. So what we can do is, and of course, yeah, I like positive cylinder. Negative cylinders, I don't think many ophthalmologists look at that. Okay, so for the next eye, same patient, so we just click back to patient data. Okay, now we're going to take a look, and I'll just move this on over to the other side. Actually, you know what? I'll make this a little. I'll just scroll over here. Sorry, I'm going a little slow. I don't want to review any patient data. Okay, so all of this is going to be the same for the other eye unless we're going to change the lens, which we typically don't mix and match lenses. Not that that's bad, but okay, so now that we're on the left eye, K1 is 40.27, so 40.27, and the flat axis is 157 right here. 157. K2 is 40.76, and steep axis is 67, just exactly 90 from 157. Axial length is 23.99, and this is a good double check. It should be within about 0.2 of the other eye. So here we go. And you can spot check this for me, and let me know if anything's off by 0.2 or 0.3. Usually it's not, but it can happen. Um, but when it does happen, usually the two eyes have very different, refractions, and you can just verify that. Oh, okay, they're about 1 or 2 diopters apart. Makes sense. Okay, optical ACD is here, 2.94. Again, most of these numbers are going to coincide pretty well, although the lens powers that we select are not usually going to be exactly the same. Okay, lens thickness, again, just a placeholder. Don't have to write anything. Just write 4.5. Sometimes if you don't write anything, it doesn't spit out, answer here. And here, oddly enough, the white to white is showing 10.1. That's really odd. Usually it's the same. So not sure what that's about. If this was an ICL case, we'd probably get this person scanned on the Pentacam, or we do have a Pentacam for this patient, but we probably, if this was important, we get this patient on the IOL Master 700. Okay, so we're done here. Remember to click the left eye, so I know so it's the right eye. Pardon the pun, but left eye. Okay, so calculate. Yep, you gotta wait a little bit. Sometimes the connection is slow. So there we go. Everything's done here. Go to IOL Toric IOL there, and again you can see it's not. The other eye was 23.5. This time it's 23. Totally normal. In this case, I may not want to pick the first minus. I see that first plus is very close to 0. I'd say if it's, within about 0.05 of, or 0.05, yeah, of 0, we just go with the first plus if it's that close. Otherwise, we always go with the first minus. I think Dr. Steve Schallhorn published something where maybe you can consider up to like 0.11 or 0.12 or something, or I forget who. But for the odyssey lens in particular, I don't want the first plus. I want the first minus, unless it's like really close. And this time it is, so I like the 23. And of course, we don't have the T2. It's not even showing a T3, so we're going to go with non-toric. You can see residual still not that bad, 0.3. All right, so go ahead and save that one as well. Okay. Maybe, you can name this whichever patient, but I'm just going to do number 2 here. All right, so now we're going to move on to the next patient. So patient data, and we're going to click reset form. Or should I just leave? You know what? I'm not going to reset form. There's some stuff there that I think is good. Okay. All right, so this is another patient. This time we have IOL Master 700. You can see how easy it is to look at the 700. Basically, it has all the toric calculations. I have my Odyssey here. It has the same, biometry. Of course, it's going to have more. Now you have, a photopic pupil size, or really just kind of like a between photopic, scotopic pupil size. You've got an angle kappa, you've got the CW chord. It was split into the X and Y axis. And what else do you have? It just looks great. And you can see most of these numbers look exactly the same. This is a wonderful machine. You can tell that I like my sill on the plus cylinder. You'll see later on we've got a random IOL Master 700 that's spitting out minus cylinder. I think that's a little bit confusing. Plus cylinder, I know when I do an LRI, I always use whatever axis they tell me, but then you got to do some mental gymnastics when you, as an ophthalmologist, when they give you a negative cylinder, you have to add 90 to it, and that just is confusing and may lead to mistakes. So the other thing you can see is you've got K1s, Ks and TKs. And the difference is Ks are simulated Ks. These are, just your basically using a nomogram to predict what the posterior corneal curvature is, which does change the total corneal power. Um, but you can see when you scroll over here, total keratometry, and that's you're actually measuring the posterior cornea, and you're subtracting, you're basically adding the two together to produce this value. So this is a measured value, and this is a simulated value. You notice that they're pretty darn close, 41.88 and 41.92, basically the same. Um, What's really odd, though, is the axes are very different. They're 90 degrees apart. And that's, oh, I guess this is a low cylinder patient. So, yeah, never mind. That's, those are things that I kind of geek out about. But yeah, no worries. This is basically the same. So if you use this in your calculator, use this. It doesn't matter. Technically, you're supposed to use in all online calculators the simulated case, not the T case. The only time you use the T case is if you're going to use the Barrett II Toric Calculator, and we do that most of the time with our post LASIK patients, and that's when the TKs really matter. You'll notice the TKs are going to be significantly different from the Ks. And so for folks who know how I set this up, my TN mode here, forget where that's labeled, and TN LVC modes are very different. This is done under TN mode, which is for virgin corneas, and TN LVC is my post LASIK, post PRK smile configurations, which utilize the TK. And you can tell what the formulas are using by looking at this little box here. So right now this is a virgin cornea. We're using Ks. It's more accurate. But another patient may have had LASIK, and so you'll see it'll say LVC LASIK, and then LVC mode myopic or whatever. And then down here you'll see TK, and that's going to produce a more accurate result. Okay, so I think I'm probably presenting this one as just to show you the difference between the 500 and the 700. Oh, and okay, so we're doing a virgin cornea. This is probably going to be an Odyssey case. So you can see we're going to pick the first minus. You can see that they bolded this. They usually pick the right lens for us. And so, yes, on the right eye, we're going to pick a 24 diopter lens. You can see that if I use a non-toric lens, 0 here, I'm going to end up with very little SIL, 0.38 SIL, which is significantly better than if I use the first toric up, which is 1.5 diopters, which is going to give me more SIL, so I don't want to use that. When we do have a case where we choose a toric lens, the toric axis is actually here. Don't get confused with this number. This number is the incision, where you're putting an incision at 0. So it's really confusing. I wish it didn't have that. But this is actually where you're lining your toric lens up. The little number, super confusing. Wish they could change that. And then obviously you can see here, if we're going to use the toric lens, which, no, we wouldn't use the toric lens here either. I know it looks smaller, but it's not worth the, risk that the toric lens might rotate out of place or something like that. Anyways, but if you were going to put that toric lens in, you'd rotate that lens to 7 degrees, and that, I don't know if that says 5 or 0, but this one I can tell is 7. Anyways, and then the which power to choose for this high, the 0.10, a little bit more plus, the first plus or the first minus. I think my preference here, since this is, a little bit more than 0.5 or so, is I think you can use this, but I think the Odyssey performs better when it's just from my experience with it, when it's you know down to 0.27 is no problem and should perform just fine. It has a very, very flat peak to the defocus curve, so that's good, and it can tolerate a lot of more plus and more minus both ways for the distance vision. All right, next one. Okay, so we're back to 500s. So let's calculate this one. We're going to slide this back on over, and that way we're not confused by which eye we're doing. So remember, we're going to do the right eye. I didn't click reset form. I think you should always do that, but just for the sake of this tutorial, let's not do that. Okay, so this patient's initials, doesn't matter that you'd obviously plug in their MRN there, and then of course these numbers are going to be the same. We're still going to do the Odyssey lens. Okay, so we're going to plug these in. So for this patient, 42.72 tab 1 tab 43.55 tab 91 tab axial length 23.11 optical ACTs 3.21. These are always the same, and then white to white is going to be 11.5. Okay, and then calculate. Again, wait a few seconds. Sometimes it takes longer. Yeah, there we go. So now you can see that they plugged in the axes. It's done. Now go to Toric IOL, and here we go. Let's take a look. This is obviously really helpful. It's telling me if we're going to use a toric, we're going to line it up at 92 degrees. Let's see if we do need a toric. So the lens power is going to be 23.5, and it's going to give us minus, the first minus, and I'll take it. That's a nice one. And it's saying, yeah, if I use a non-toric, I'd have a less astigmatism. We're going to stick with non-toric, no problem. So this doesn't matter anymore. This is if you choose to do the T2, but we don't have T2 in America, and it's neither one. They're both very low residual sil, and using a non-toric is, in my opinion, looks better. Keep them at with the rule, with less sil. That's perfect. So yeah, the blue is sometimes wrong, and if it was a little more worked out, it would put the blue highlight over this lens. Okay, so that's the lens we picked, non-toric 23.5. Let's save that. Save. And I think this is the third eye we're doing. Okay. And now we go back to patient, and let's do the other eye. So left eye now. We'll slide this on over. Review that left eye. And all of this you don't have to change. Okay, we'll start again here. 43.10 to 43.38, 92, 23.14. And you see that there's not much difference between axial length between the two eyes. It's 99% of the time just like that, but 1% of the time it can be off a little bit. But when it's off, do flag that for me. Sometimes it's it's a spot check where maybe the scan was done wrong, and maybe we should scan the patient again, and not maybe, but we should scan the patient again. Okay, optical ACD is 3.26, and then white to white is the last thing I need, which is 12.5 here. And again, I don't know why the 500s white to whites are so odd and off. You don't expect that. The two eyes are not going to look like different sizes. you know, the color parts of the eye. So that's really weird. I think it doesn't do that very well. Okay, calculate. And good. And then toric IOL. All right, so for this eye, yeah, I think the 23.5 looks good too. So in this case, it's picking the same power lens both times. And then again, I wouldn't use the T2, even if I had in America. I'd use the non-toric. It's going to give me, um, you know, some people say, you know, with the rule up to about 0.5 diopters is nice and enhance the reading ability. No, I don't. I think you just want the sill like as close to zero as possible. I would go with this one, even if it's against the rules. So non-toric, of course, 23.5. Let's save this one. I think this is our fourth eye. So yeah, it's a lot of number crunching, and one thing that I'm not showing is that you should be double checking your data and just make sure there's no transcription errors, because that'll be bad. I think my computer has crashed. Well, we'll just end this video here. I'll continue in another video.